So in this video, I will be discussing Codeforces around 976 rated for division 2. So I will be discussing first two problems of this set. Let's start with problem A, that is minimum operation. So in this question, we are given two integer number n and k. So we have to find there is the operation given to us. And what is the operation? We can subtract any power of k from n. Okay. More formally, you can see the definition over here. Okay, done. Now what to tell them? Minimum number of operations required to make n equal to 0. Okay. So this is the question given to us. So how can we solve the problem? So let's now illustrate the problem with respect to 2. For example, if we are given a number, for example 10. Okay. So how do we initially solve the problem for 10? Like we will break the 10 into power of 2, right? Which means it can be broken down easily like I think so 0, 1, this is 2, 4, this is 48. So this is the binary representation of 10, right? So how many ones are there? So there are total 2 ones, which means we will require 2 powers of 2 to make 10 equal to 0. One is 8 and another is 2. Yes. So this is how we will solve the problem if my k is equal to 2, right? So this thing we know. But here k is variable. Okay. Here k is unknown. So how do we solve the problem? So answer is pretty much simple. For example, if I am given a number like let's suppose 50, I am given a number 50 and k is equal to 5. Okay. So how do we solve the problem? We will just break the 50 into powers of 50. We will just break the 50 into power of 5. But how can we do that? Just simply using the modulus operations. For example, like let me show the code only. Okay, I think so. I will tell you here only. So first of all, 50 is there, right? So I will try to break, like if my 50 modulus 5 is equal to 0. If my 50 modulus 5 is equal to 0. If yes, okay, then add 0 in your answer. For example, this is my answer variable. Okay. Now divide 50 by 5. That is equal to 10. Okay, done. Again, is my 10 divisible by 50? 5. Answer is yes. So here the modulus will be 0. Again, divided by 2. Again divided by 5. That now it remains 2. Now 50 modulus 5. What is it? This is simply 2. Okay. Now add 2 your answer. So is my answer 2? Yes, my answer will be 2. But how? Like what are those two powers which are giving me 50? There are 25 and 25. Okay. Hope so this is clear too. So this is the thing which we will do in power of 2 only. Just replace 2 with k. Right. So I will show the code. Take the number. This is special case also, like if my case would 1, then simply print n, because the every other power would be 1 only. So this is the count operation method. So which is simply taking n and k, and I'm iterating till my uh, n is greater than 0, and adding n modulus k in my answer, and doing n by k at each and every step. And this is the operation. This is the N operation would be the sum of each and every modulus power of my n modulus k. So that is how you can solve problem number A. Let's now discuss problem number B, that is brightness beacon. Yes. So, like in this question, we are given n light bulbs, number from 1 to n. Okay. Initially, they are all on. Okay. And a flip state is simply make the on bulb off and off bulb on. Right. So, what we can do next? For each and every I from 1 to n. N is the number of bulbs also. From 1 to n, flip the state of all the bulbs from j such that my j is divisible by I. Okay. After performing the operation, there are several bulbs which are still on. And our goal is to make the number of that bulbs exactly equal to k. So how can we make that? So to solve this problem, you must know a fact. Okay, this is not a fact. Or you can simply search on Google also. Like let me try it for you. Like I think so bulb fill puzzle. You can search it, and this is the link which I got it. Yes. So simply search and just read this. I will give you the link in the description also. So you can just get the proof over here, but I'm trying to say now. Okay. So if there are total 100 bulbs, right? If there are total 100 bulbs, okay, and we will tell them what are the number of bulbs which will be on. initially they are all on. Okay, and we have to tell them what are the number of bulbs which will be off. Okay, I'm talking about off, which will be off at the end of all the operations, which means for each and every 1, 2, 3, we will flip all the bulbs which are divisible by 1, 2, 3, 4, and 4. So the number of off bulbs would be square root of 100. Yes. Okay. If this is the number of off bulbs, you can get the proof over here. Okay. So now tell me what are the number of on bulbs. So if the number of off bulbs are square root of n, the number of on bulbs would be n, number of on bulbs would be n minus square root of n. Yes. So what is simply problem asking us to do? The problem is simply asking us to do is simply find the, here you can see, find the smallest suitable n such that after performing the operation there should be exactly k bulbs out. Okay, which means we have to find the smallest n. We have to find the smallest n such that this is my uh, which is greater than and equal to k. Okay, smallest n such that which is greater than and equal to k. Right. So this is the question asking us to do. So how can we find it? We can simply use a binary search approach to find this particular equation. How a binary search approach will work? So you can, we have to find the smallest n. So you can simply use the binary search. For example, my initially s would be 0, and my end would be like, it would be very big number, 1 19 or 18 you can take. So loop till, like for example, make a checker function which will take a variable n and just return if my n minus n square root of n is greater than or k or not. Okay, this is my checker function. Okay, done. Now run a loop, like this, my mid will be s plus e. By the way, I can show the code also, but yes, okay, I will show the code only. So this, so my low is equal to 1 and my high is equal to 1, 2, 2 to raise power 18. Okay, 2, and there furthermore 18 zeros in the end. And mid. So what is my mid? Mid is simply low plus high divided by 2. Then this is my check function. Check function is simply counting, like if my n minus square root of n is greater than k or not. If it is greater than k, then I will shorten my range, because you can see I'm making my high is equal to mid. It means I'm shortening my range. I'm making high is equal to mid, and else I'm making load is equal to mid plus 1. Okay, and at then I know the answer would be low only. So that is how you solve problem B. But you must read, I think so, this link must be very useful to you to solving this problem. So that's all for this today's video. And like, in the, I think so, in the previous video I have messed up with the D's explanation, so apologies for that. So like, it won't happen for the next time. So that's it for today's video. Thanks for watching. Bye.